Okay, here we are in lesson 2.5. This is the last lesson for chapter 2. We are going to be solving compound inequalities, and this might be a new topic for you. All right, so what are we going to learn? We are going to learn how to write and graph compound inequalities, to solve compound inequalities, and use compound inequalities to solve real-life problems. So this is a pretty important slide, and I do not believe that it's in your note-taking journal, okay? But it is in your textbook, so you can see it, online in your textbook. So what we're talking about with a compound inequality, it's an inequality formed by joining two inequalities with the word and or the word or, okay? So when we are doing like the graph of a compound inequality with and in it, it's the intersection of the graphs of the inequalities. So like x is greater than or equal to 2 and x is less than 5. So another way of saying that is within, right? It is within the range of 2 to 5. So you can notice how they graph it. They first graph like the x is greater than -2, then they'll graph the x is -5, and then you can kind of see how they're highlighting. I'll get a different color here. They're kind of highlighting just that part. You don't need just the part where they overlap is what we're talking about. And notice that because it was greater than or equal to 2, there's a closed circle, and it was less than 5, it was an open circle. So our and inequalities can be written like this, right? We want to kind of conjoin those and show 2 is less than or equal to x, which is less than 5. On the right, we have the graph of a compound inequality with the or. It's the union of the two graphs, right? And it shows numbers that are solutions of either inequality. So, because it's or, either or. So it's either less than or equal to -2 or it's greater than 1. But usually there's that gap in the middle. So we will have arrows pointing in opposite directions, and we will continue writing it as separate inequalities separated by the word or. So let's give a few of those a try. We'll probably look at some examples first. All right, so writing and graphing compound inequalities. So first we want to look at this. So write each sentence as an inequality and then graph it. A number x is greater than -8 and less than or equal to 4. So since this is an and inequality, we know that it'll be like the between, the intersection of the two graphs. So we have a number x is greater than -8, x greater than -8, and then we also have x is less than or equal to 4 because of the less or equal to wording. So you can go ahead and write it. Whenever we have an and inequality, take the two numbers and you'll put them in, it'll be like least to greatest going left to right. Okay, so that'll help you to know which one to write first. So we write the -8 is less than x, which is less than or equal to 4, and graph it. For part B, a number y is at most 0 or at least 2. So we have two different things going on here. It's an either or situation. So we'll have two graphs, but they'll be pointing in opposite directions because y will either be less than or equal to 0, or y can be greater than or equal to 2. But notice it's not equal to that range in between 0 and 2. Well, actually, 0.1 and 0.99999. Okay, so yeah, there's going to be a gap in the way that's graphed. So we get a chance to try these. Here we go. This is on page 51. So we have a number u. We have u is less than 7. Okay, so I'll kind of write it off to the side. U is less than 7, and u is greater than 3. So we have these two things to connect. Okay, so on your graph, you're going to want to number it so that we have a few numbers on either side. All right, we are going to have an open circle at 3, and we will have an open circle at 7. And I know I said to continue it on, so we probably could make a few numbers on either side. And it'll be the numbers between here are solutions. And the way we would write this is like this. We'd start with the 3. So 3 is less than u, which is less than 7. Okay? This is an and inequality, and we got that information right here because it was talking about the number u less than 7 and greater than 3. Okay? Less than 7 and greater than 3. It's the range of numbers in between there that satisfy that situation. All right. Next up, number 3. So we have S, no less than negative 2.4 and fewer than 42. So again, we have this and. So we're talking about the intersection of these two graphs. And the graphs are going to be, so S is no less than negative 2.4, right? So S can be equal to that, but it can't be less than that. And what's the other one? Fewer than 4.2. So if S is fewer than 4.2, it doesn't mean that it's equal to, right? So to write this, we could say that, okay, we start with the negative 2.4 because that's the least value. And then that is less than or equal to S, which is less than 4.2. So here is our compound inequality that's showing both things. And then we'll want to, let's see, number it. I kind of did it like this. So I can do like negative 4, negative 3. All right. And then when I'm going to graph this, when I have my negative 2.4, it's going to be a solid circle. Okay, and you might want to write above that what it is since it's a decimal. And then it's going to be an open circle at the 4.2, and then all of the values in between are connecting those two values. So negative 2.4 to 4.2. Okay? If you're having any questions with these, make sure that you write them down so that you can be sure to ask in class when you're with the teachers. All right. So now we're going to have number C is more than negative 4 or at most negative 6.5. So we have an or, and this means that it is either or, and the graphs should be pointing in opposite directions with a gap in between. So the two that we are going to graph is we have C that is more than negative 4. It didn't say it was equal to, so it was simply more than negative 4. Or C is at most negative 6.5. So that means that it can be equal to, but it can't be greater than. So negative 6.5. So if I'm going to graph these, go ahead and do our number line. Okay, and then we will have an open circle at our negative 4, and C is greater than this, right? And we have a closed circle at negative 6.5, and X or C is less than that. So this is negative 6.5, and that's negative 4. All right, so notice that they're pointing in opposite directions. So if somehow you're drawing the graph and your graphs overlap on an or inequality, then maybe you've mixed up the symbol and you want to reevaluate the symbol. And if you recall back in lesson 2.1, there was a text box in the slide and in the notes that kind of showed all the different words and all the different meanings of the symbols. So that can kind of help you practice that as well if you need to look backwards. Okay. So solving the compound inequalities. You can solve compound inequalities by solving two inequalities separately. When a compound inequality with and is written as a single inequality, you can solve the inequality by performing the same operation on each expression. So what we're doing in this example, okay, you can see these are the examples of the and inequality. So they're going to show you two different ways to do it. In part A here, what you're looking at is you're looking at two different inequalities. So you can look at this half right here. Oops, that kind of covered up the two, or you can look at this half right here, which starts with the x and goes all the way over to the 3, okay? So here's the equation that I just boxed in blue, and here I'll show you what the red one looks like right here. So we're solving both of these situations, right? So what we're going to get is two solutions. We get this -2 is less than x and x is less than 5 that can be written like this and graphed as such. But here's something else that we can do. When we have the compound inequality, notice that we're going to be, notice at this step, we had to add 2 to everything, right? Because in order to solve the x minus 2, we had to undo that subtraction by adding 2. So in B, they're looking at this middle section and they're saying, okay, we need to get x by itself in this middle. So what's something we're going to do? Well, we have to subtract 1 to undo adding 1. So we're going to subtract 1 in the middle, and we're going to subtract 1 from the 9, and we're going to subtract 1 from the -3. Okay? Simplify that. We're still left without isolating the variable in the middle. So to do that, we have to divide by a negative. Now, remember the rule. If you're dividing by a negative, you have to reverse the inequality symbols. So since you're dividing by a negative on the right, from a less than and equal to, you have to change it to a greater than and equal to. And on the left, you'll have to change it from a less than to a greater than. So that then you'll have 2 is greater than x, which is greater than or equal to -4, right? And if you want to put it in least to greatest, you could graph it, the other way. You'll get -4 is less than or equal to x, which is less than 2, and you have one closed and one open. So let's give those a try. This is number 6. All right, so for this one, I'll break it up and do 2 different ones, okay? I will do like this, and then I'll change colors, and I'll do this so you can see the 2 different equations. Okay, we have one equation that looks like this. And we know it's an and inequality because of the way that it's written. And we have another inequality equation that looks like this. So notice that when we're solving this, we will be adding 3 to both sides. And even in the blue equation, we will be adding 3 to both sides. Okay, so that if we put it all together, we would have 7 is less than x, which is less than or equal to 10 as our and inequality solution. All right, so to graph it, we have an open circle and a closed circle and all the numbers between those two things. All right, so that is our solution. So if you have any questions about that, try to think about where it is that you're not understanding so that you could be sure to ask when we're in person. Or if you're remote, you'll want to ask through email or on Google Meets. All right, now we're going to do number 10. And on number 10, we're going to do the other way that they showed us, okay? So the first thing we're going to do is kind of simplify. We have to get rid of the grouping symbols. So we're going to multiply this 1/3 times everything in there. So we're going to rewrite the whole thing. It's less than or equal to. So a third of 6x is 2x. Actually, scratch that. I'm sorry. We totally could distribute that, right? But in looking at this, since it has not been distributed yet, if I multiply everything by 3, right, that kind of gets rid of this fraction, so we don't even have to distribute before we solve. But if you did distribute before you solve, it's not that big a deal, okay? So then I'll rewrite it, and I'll have negative 24 is less than or equal to, and then I'll keep the 6x plus 24 in the middle, which is less than or equal to, and then 12 times 3 is 36. Oops. Okay, so now I can come through and subtract 24 from all parts. And I would get negative 48 is less than or equal to 6x, which is less than or equal to 12. Final step, I'm dividing by 6, and it's a positive 6, so it does not reverse symbol, so you have to stay very conscious of that. So negative 8 less than or equal to, I have finally isolated the x, which is less than or equal to 2. And notice now that when we get our answer, we don't have to put it in that least to greatest order because we've solved it maintaining that notation of the and compound inequality. So we're just, whatever we're doing to each part, right? We have to do it to the left, the middle, and the right. The left, the middle, and the right. The left, the middle, and the right, and so forth. Okay, so now we can graph it. I'm going to count by 2s here, I think. Looky there. All right, and so I go from negative 8, which is a closed circle, and 2, which is also a closed circle, and it's an and inequality, so we're talking about all of the numbers in between these two. So negative 8 to 2. It's kind of like a range of numbers, okay? All right, a couple more. So what about the or inequalities? Well, the or inequalities are written as 2 separate inequalities, so you solve them as 2 separate inequalities and make sure that when you graph it that they point out. So let's go back to number 9. Number 9 was an or inequality. So number 9. So we can solve this one by subtracting 6 from both sides. So we'll get 2t is less than 4, divide by 2, divide by 2, and we'll get t is less than 2. Okay? Then, or we'll subtract 7 on both sides. So negative t is less than or equal to 2 minus the 7 is negative 5. Now we'll divide by negative 1, and we'll have to reverse the symbol to be greater than or equal to 5. So we have t is less than 2, or t is greater than and equal to 5. So let me write some numbers here. All right, and so if I graph these, I have less than 2, so open circle, and it points left. And then at 5, I have a closed circle, and it points right. So there should be a gap in between so that we did it correctly. Okay. Moving on to the word problem. A certain machine operates properly when the relative humidity satisfies this inequality. So we are given the inequality and we're looking for the range of values. So this is the and inequality. So I'm going to start by going ahead and writing the inequality down here. So negative 60 less than or equal to 2 times h minus 50. And I love it when they don't have it already distributed. All right, so the first step we could do is we could divide by 2, and that would cancel this 2. So we also have to divide by 2 here and here. So negative 30 less than or equal to h minus 50 is less than or equal to and another 30. Well, next step, add 50 to everything. Okay, so we'll get 20 less than or equal to h, because that gets our h by itself, which is less than or equal to 80. So this range that they're talking about, the relative humidity, can be 20, but it cannot be more than 80. So it's from 20 to 80. That's the meaning of the problem. All right, that should be all. And sorry this video ran a little bit long. There was a lot of stuff.